Welcome back to our class, the part 2 of the line integral. We have considered line integral over a closed field. We have considered an example. This is another example. We want to evaluate this line integral where C is the triangle having these vertices, having these points as vertices. You can see a triangle is a closed region. Now, we start from C1. We move from 0 A to B, 0 to 0, 0, and B is 1, 1. So we are going to make use of the formula for equation of a line that I gave the other time. This formula, we make use of it, and when we make use of it, we are going to have y is equal to x. When you are on your own, you cannot jump like this. You have to use the formula and get your answer. So we got y is equal to s. When we differentiate, the y is equal to dx. When we differentiate, we have 1, we put dy. Differentiate x, you have 1, we put dx. Now, I will not come to this place, which is our C1. Y. We have said here that y is equal to s. We have shown there. This is y. Our y is x now. Dy. Our dy is dx plus x minus 2y. Our 2y is, our s is just y. So it's just 2x. Then dx. So everything is in terms of s. So we are going to make use of this 0 to 1. 0 to 1. They are the same thing. This is minus s. This will give me minus s. This will also give me minus s. So we are going to have minus 2x dx there. So when we integrate, we have minus s squared, 0 to 1. And that should give me minus 1. When we put s to be 1, 1 squared is just 1. So minus 1 is our answer. That is for our high one. Now for C2, so I've moved from A to B. I will now move from B to C. Our C2 is B into 1, 1 and C into 1, 2. When we make use of the equation of a line, we are going to have, okay, don't let me jump this. You need to understand this concept. You know, the formula is y minus y1 over s minus s1 is equal to y2 minus y1 over s2 minus s1. So we are going to have y minus y1. This is our y1. This is s1, y1, s2, y2. Y minus y, our y1 is 1 over s minus s1 is equal to y2 minus y1, 2 minus 1 over 1 minus 1. This will give me 1 over 0. Now, when you may encounter problem when you get to this level, because what we have now is y minus 1 over s minus 1 is equal to 1 over 0. When we get to this level, when 0 is at the denominator, just bring it up. Bring this one to up. This will be s minus 1 over y minus 1 is equal to 0 over 1. So you interchange like this. So from this place, this will be 0. 0 over 1 is 0. And if you make this, if this one goes there, it will be 0. So what we are going to have left is s minus 1 is 0. So what we have here is s minus 1 is 0, or we say s is equal to 1. Therefore, ds, if you differentiate 1, that is 0. ds is 0. Let us bring it back here. Then our height 2 is equal to y, we don't know y, minus 2x. Our x is 1, so it's just 2 times 1, 2. We don't know the y. Whatever this may be, this ds will make it vanish because ds here is 0. So 0 times whatever this one will give me is 0. So let's forget about it. So this is dy, it's not dx. So everything now it is in terms of y. So we have to make use of the boundary of y. That is 1 to 2. 1 to 2. Where we integrate, we have y squared over 2 minus 2y, 1 to 2. So anywhere we see y first, we put it as 2. This is 2 squared over 2 minus 2 into 2. Then you say minus, anywhere you see y, you put it as 1. This is 1 over 2 minus 2. And when we simplify, we are going to get, so we got minus half. Now, it remains C3. We have moved from A to B, B to C. It will now be C to A. Our C is 1, 2, and our A is 0, 0. So we need to find the equation of a line. When we find it using the formula, we'll get y is equal to 2s, and if you differentiate, the y will be equal to 2 if you differentiate 2s, or you must put the x there. Therefore, our I3 will become, we use this y, we have been told that y is equal to 2x. That is 2s minus 2x dx plus s minus 2y. X minus 2y. This is our y here. 2x, then dx. The y here is 2 dx. So dx has no representation. 2s minus 2s is gone here. But everything is in terms of x. So in that case, we have to use the boundary of s. That is 1 to 0. So this will give me 1 to 0. This is gone. It remains this. What we are going to have is, this is 4s. That will be minus 3x dx. We can interchange this boundary. When we interchange this boundary, this minus will leave. That is, it will be like this, 0 to 1. It will now be ordinary 3s instead of minus 3s, because we have interchanged the boundary. So integrating this, we have 3s squared over 2, 0 to 1. So when we put s to be 1, we are going to have 3 over 2 as our answer. So we have found I1, we have found I2, and we have found I3. Finally, we can get our answer. Therefore, our I1, our I is equal to I1 plus I2 plus I3. Our I1 there is minus 1. Our I2 is minus half. And our I3 is 3 over 2, which after simplifying will give me 0. So that's our answer. The value of the integral is 0. So let us now consider a line integral over a surface S. In this case, we need to recall from the elementary calculus that ds is same thing as square root of ds dt squared, dy dt squared, then dt. So the only problem we can encounter is that how can we write s in terms of t and y in terms of t when we have an equation of it, when you have 2 points. Now let's consider this. Let's assume that equation of a line. So this is another form of equation of a line. Let's say between AB and CD. The equation of a line is being written as A comma B plus T into C comma A C minus A comma D minus B. So this is another form of, with this we can parameterize this equation, that is, we can get a parametric equation. Let's assume that we are given this. We want to find the equation of a line between these two points. This is our A, this is our B, or S1, Y1, S2, Y2. So what we just do is we say S comma Y is equal to A comma B, this first one, 2 comma 3 plus t into, what that means is that just subtract the first one, 1 minus 2, that is minus 1, minus 2 minus 3, comma, that is minus 5. This, we take the first one, this is 2. If you expand for the first one alone, the first one is here, t minus 1, that is minus t, comma, the second one, 3, t minus 5, that is minus 5t. So from that place, we can get our answer to be s is equal to 2 minus t, and y is equal to 3 minus 5t. So this is equation of a line. So we have used this method to parameterize this equation. That is, we express s and y in terms of t. Let's take example under this. So we have our example 1 here. We want to evaluate this line integral over this ds, where c is this line segment. The first thing is, before we get our s, we need to know our y and x. How do we get that? We follow what I just did to parameterize the equation. We get the parametric equation. We start by saying s comma y is equal to the first one, 3 comma 6, plus t into, you subtract this minus this, 1 minus 3, that is minus 2, comma, 2 minus this, that is minus 4. And this will now give me s comma y will give me 3 minus, if you expand the first one, that is minus 2t. The second one, 6 minus this is 4t. So from that place, we have been able to find our x to be 3 minus 2t and our y to be 6 minus 4t. Sometimes this s and y would have been given already, but in this case, it's not given. So the next thing is we need to differentiate dx dt. Dx dt. If I differentiate this, I'm going to have minus 2, and we need to differentiate this to dy dt. If I differentiate this is 0. If I differentiate this, I will have minus 4. So we cannot use our formula ds dt. Ds dt has been given as this. Our ds dt, we put it there, minus 2 squared minus 4 squared. So this will give me 4 plus 16. This is root 20, and root 20 is same thing as 2 root 5. We have known our ds. Don't forget that there is dt here, dt, dt. Let's substitute everything here. Therefore, also we need to know the bound of t. It will be less than or equal to 1. Our high will be 0 to 1 because we have turned it to t. And we are turning it to that, this will be your boundary. 0 to 1. 3s squared. 3x. This is our x here. This is our x. That is 3 minus 2t squared minus 2y. This is our y. 6 minus 4t ds. This is our ds, 2 root 5 dt. So 2 root 5, you can bring it here as constant. We are left with this. So what we are going to have left there is 3 into 3 minus 2t squared minus 2 into 6. If you expand this, that should give me 12. And this one should give me plus 8t. If you expand it, dt. This is 2 root 5. Now we are to integrate this. You should learn how to do that. When we integrate this, we have 3 minus 2t raised to power 3 over 3 times 1 over minus 2, just like you are integrating s raised to power 2. That will be s raised to power 3 over 3. That is why we have this. This 3 is constant. So also, how do we get this minus 2? We differentiated what is inside. This is integration by substitution. Plus there is 12 here. This is minus 12 here. If I integrate minus 12, I will have minus 12t. There is plus 8t here. That will be 4t squared. 0 to 1. Let's simplify further. This cancels this. All we have left should be minus into 3 minus 2t cubed over 2 minus 12t plus 4t squared. 0 to 1. So we substitute t to be 1 anywhere we see our t. If I put t to be 1, you see that we are going to have 3 minus 2 because t is 1. So 3 minus 2, that will be 1 cube over this 2 minus this 12 plus 4. If you put t to be 1, 4 times 1 is 4. Then we always say minus when t is 0. If t is 0, the whole of this will be 0, but there's still another 3 here. So so this will be minus into minus 3 cube over 2. The whole of this will be 0. If you put t to be 0, it will nullify the whole of this. Now this will give me 2 root 5 into, if I now simplify this further, I'm going to have, using your calculator, give me 5. Finally, our answer is 10 root 5. So it's the solution to this integration. Now let's take another example. So we have example 2 here. We want to evaluate this line integral where c is this parametric curve and t is giving us 0 to pi. Thank God here we don't need to, it's not like the other one that we found the value of s and y. Here we have been given the expression for s and y in terms of t. Now s is equal to 3 cos t. I will differentiate, okay, y is equal to minus 3 sin t. I will differentiate it, ds dt. ds dt is equal to, if I differentiate this, I will have minus 3 sin t. dy dt. If I differentiate this, I will have minus 3 cos t. Then we need our ds. ds will be equal to this. This will be equal to our ds dt. We substitute it. That is 3 minus 3 sin t squared plus the second one minus 3 cos t square, then dt, where we have substituted dy dt here. Now if you expand, this is 9 sin square t plus 9 cos square t dt. Remember, 9 is common and square root of 9 is 3. 9 is common, square root of 9 is 3. I will bring it out. What we have left is sin square t plus cos square t dt. But let's recall that sin square t plus cos square t is equal to 1. So the answer there is just square root of 1, which is 3. So the answer is 3 dt. So we have known our ds. I will now substitute it here. Therefore, our I is equal to 0 to pi. That one is given here. 2s squared. 2x. This is our x. Our x is 3 cos theta. But we have s squared there. That will be 3 cos square t. And then y. This is our y here. Minus 3 sin t minus 4s minus 4. This is our x that is 3 cos t, then ds. This is our ds here, 3 dt. Now, some values are common there. Let's first simplify. This 3 must first come out. This 3 here must first come out. This one, there is 3 here. There is 3 square. That is 27 times 2. That is minus 54 cos square t sin t. And this one, there is 12 here. Minus 12 cos t dt. Now, it's now easy for us to integrate. We use integration by substitution to do this. Let me first write this minus 54 down. You remember when you integrate, when you differentiate cos square, cos, you get minus sign. So in this case, if I integrate this, I should have cos cube t over 3. There is minus sign there. That is the answer. Minus 12. If I integrate cos t, I will have sin t. Then 0 to pi. Now, that will be an assignment to you. How this thing becomes what is here. The assignment is that you are integrating cos square t sin t dt. And I got minus cos cube t over 3. Now, this one becomes minus 12 sin t, 0 to pi. This is 3 into 18 cos cube pi minus 12 sin pi. Also minus, anywhere we see t, we put it as 0. This is minus 18 cos cube 0. The minus will make this one to be plus 12 sin 0. This is 3 into cos pi is minus 1. No, pi is 180 degrees. That means cos 180 degrees is minus 1. Then minus 1 cube is still minus 1. Sin pi is 0, so we don't need to consider it. Then minus 18 into cos 0 is 1. Also, sin 0 is 0. So what we have left is 3 times, this should be minus 18. Minus 18, that should be minus 36. And when we multiply it together, we have minus 108. So that will be the answer to this question. So you can take this as an assignment, study this as an assignment. You can try it. Have a nice day.